in this video, we're going to be going over surface area and lateral area again, but we're going to be talking about pyramids and cones now. So remember that surface area is the area of every single face of the object, whereas lateral area is we're still taking the area of faces, but we are not including the bases in this calculation. So it's important to first know the difference between a prism and a pyramid. So we've been working with prisms in the previous lesson, where now we're going to be dealing with pyramids. So both, in this case, in this specific example, this is a rectangular prism and a rectangular pyramid. So the difference between prism and pyramid is that a pyramid is coming to a point. So both of them still have these wonderful rectangular bases. But in a prism, we are not coming to a point, whereas in a pyramid, we are. So we can kind of see how that affects the other shapes that are involved, right? Like here we have a rectangular base, but in order for us to come to a point, the other four sides that are included are going to be triangles. So pyramids are going to have a bunch of different bases, but all of them are going to come to a point. They're going to utilize triangles as the other sides, and just know that the first word of the pyramid tells you the shape of the base. So for example, a rectangular pyramid has a rectangular base. A triangular pyramid has a triangular base. A square pyramid has a square base. Now, there are some important properties of a pyramid that we need to know. So just make sure if you don't have this diagram in your notes that you kind of utilize this one and label some important things. So the base is obviously this face at the bottom. But then we have some other important things. We have something called the slant height. Now the slant height is like this measurement of each of these parts of the triangle there. That's your slant height. And then we have our altitude, and our altitude is the portion that's coming down like the height. And remember that the height or the altitude creates that 90-degree angle, okay? So for surface area of pyramids, this is the formula here. So surface area is A plus 1/2 of PS. Now, A represents the area of your base, right? So whatever your base is, if it's a square, if it's a rectangle, A is going to be the area of your base. So what I want you guys to label, right, is that this is your base. And in pyramids, there's only one base, right? Remember for prisms, there was a base at the top and the bottom. For pyramids, there's only one base. And then these are the area of your lateral, I'm gonna shorten that, lat faces, right? So if we want the surface area, we take both of these measurements in, where P is your perimeter of your base and S is your slant height. But if we just wanted the lateral area, remember, we're not going to include the area of the base anymore. If we just want lateral area, we're just going to be talking about this portion. So let's go ahead and do a quick example. So let's find the surface area of this diagram here. So our total surface area is A plus 1/2 of PS. Now I like to make a list of our variables. So P is our perimeter of our base. So our perimeter of the base is going to be 11 plus 11 plus 11 plus 11. So we have 44 for our perimeter of the base. And S is our slant height. That slant height is nicely given to us as 15. And then the area of our base is going to be 11 times 11. It's going to give us 121. So now we just have to go ahead and substitute in. So our surface area is going to be 121 plus 1/2 of our base perimeter, which is 44, times our S, our slant height, which is 15. So now you can go ahead and put this into your calculator. Be sure you're mindful of your parentheses. And we would get 451 meters squared. And remember, that's your total surface area. If we wanted lateral area, we cannot include the base anymore, which means that from this formula, I'm going to take this A out. I'm taking my area of the base out. I would just use 1/2 of PS, and we already have that here. So that's this portion of our formula here. So our lateral area is just 1/2 of 44 times 15. And that's going to give us 330 centimeters squared. Cone is the next shape that's up. So a cone has a circular base, but it still comes to a point. Kind of think of like a party hat. And the properties of a cone are the radius is a part of our base there, right? we have a height of our cone, and that height is usually measured from like this middle point here, and remember that heights create that right angle. And then we have something else similar to pyramids. We have our slant height, and remember, slant height is pretty much exactly the same what it was for a pyramid. Our slant height is this like measurement on the side here. Now, for the surface area of a cone, remember we need the area of all of the faces of our shape. So our base is a circle. We already know how to find the area of a circle, right? The area of a circle is pi r squared. So you want to make sure you write the formula down and also write base above pi r squared. Now this pi rs represents the lateral face when that cone is opened up and separated. So this picture gives a nice little demonstration of separating the cone. So we have our circle as the base on the bottom, and then this turned in piece is going to kind of open out, and to find the area we do pi times r times our slant height. Now there might be some examples, if you have all these variables then that's great, but there might be some examples where you don't have the slant height and you might have to solve for it. We know that we need this value of s. So here it gives us the diameter of our circle is 6. So we know, okay, that this value here is going to be 3. Now we should get in the habit of trying to digest these diagrams here. We have a right triangle. And when we have 2 out of the 3 sides of a right triangle, we can go ahead and use Pythagorean theorem to help us figure out what that third side is. So a squared plus b squared equals c squared. So we get 10 squared plus 3 squared equals c squared. So we get, if we do this, we get 109 equals c squared. And then if we take the square root of that, we get 10.440. And always take a step back and think about what this represents. Well, what that represents is this slant height right here, 10.440. Now, if we want our surface area, all we need to do is plug everything into this formula. So our total surface area is going to be the area of our base, which is this circle right here. That's pi times r squared, so pi times 3 squared, plus pi times our radius, which again is 3, and then our slant height is what we just found as 10.440. And if we simplify this, we get surface area is equal to 9 pi plus, now my calculator, I'm going to put 10.440 times 3, and that gives us 31.32 pi. We're getting weird numbers here, but that's okay. And if we want it in terms of pi, we just add that 9, and we get SA equals 40.32 pi, and that's going to be feet squared. Now, if we wanted the lateral area, remember that lateral area is the area of every face except the base. So in this formula here, our base is represented by this pi r squared. So if we wanted lateral area, we don't utilize that. We only utilize the pi rs, or the pi r L, right? And L and S are the same, it just means slant height. So we get pi times our radius, which we have, times our slant height, which we also have. And if you notice, we already did this before. We did this up here. That's this right side of the equation. So our lateral area is 31.32 pi feet squared. Okay, so sometimes knowing these formulas is great. Just be careful with your cones. You might have to actually use Pythagorean theorem to find that slant height, but then you'd be good to go to just substitute in.